Are we okay with this here now? Doing this resistor problem? We're good with that? All right, so now it says, number 4 says, combine the last two and redraw. These are in what type of circuit here? Parallel. So we use the 1 over now, right? So it's 1 over 6 plus 1 over 12. So that's 2/12 plus 1/12 is equal to 3/12, which is a quarter, right? So 1 over would be 4 ohms. So if we do that, now we get a final circuit that looks like this. So while we have all that combination of series and parallel circuits, all the battery sees is one resistor equal to 4 ohms. That's all it sees. Okay? Good? So now let's work our way back up. So we've packed it all in. Now we can unravel it to find out what these individual voltages in currents are. All right? So determine the total current. All right, well, V equals IR. It's going to get 12 volts. The total resistance is 4. So the total current through the whole thing is 3 amps. Good? We're good. Okay. Awesome. So now let's label each resistor at the left with its current and voltage. So now now we know some information. Okay? In a parallel circuit, because now we're unraveling it, what does each resistor get the same of? They get the same voltage, right? So how many volts does the 6 ohm get? Gets 12 volts, right? How much does the 12 ohm get? Right, okay. So voltage for the 6 ohm gets 12 volts. The voltage for the 12 ohm gets 12 volts. Okay? Because that's, again, just the property of a parallel circuit, that everybody gets the same voltage. Think about the ramps, right? That little GIF I had. They both had the same height ramp. Correct? And then they slid down. So using that information and the resistance, can we find the current? Right? We do V equals IR for both of them. Where you get 12 volts, it's through 6 ohms. So that guy, the 6 ohm guy, gets 2 amps. Correct? This one gets 12, and it gets 12 ohms. So he gets 1 amp. So this is real interesting right away. In a parallel circuit, we found out that the total current is equal to the sum of the individuals, correct? So we found down here that he's going to get 3 amps, right? The total is 3 amps. For this circuit, the sum of 3 needs to be split between these two. 1 and 2. Okay? Now, are we done with this guy? We're done with the 6 ohm resistor? He's done, right? He's kaput, because everything else happened in this branch. Okay? So let's go back up. Now we've got a series circuit right here, correct? Because this 12 is actually a 9 and a 3. Okay? So let's think about this. In a series circuit, what does every resistor get the same of? Current, right? They get the same current because the water has to flow, all the water has to flow through both of them. If you're thinking about a hose, it has to go through all of them like that, okay? So, how much current does the 9 ohm get? 1 amp, right? Because we determined over here, through the 12, right? We determined that it was 1 amp. Correct? But the 12 was really these two together. So they both get 1 amp. Good? So the 9 gets 1 amp. The 3 gets 1 amp. Okay? So now we got to find the voltage. Let's use Ohm's law. Right? So we get 1 amp through the 9 ohm resistor. So he gets 9 volts. Right? And I'm curious, can you predict? Can you predict what the voltage through this other one is? If this gets 9, how much does this one have to get? 3. And this is 1 amp times 3 ohms. So it's 3 volts. Okay? Let's think about this. In the previous problem, we said that this part is going to get 12 volts, right? And then in a series circuit, the total voltage of 12 is the sum of the individuals. So this is going to be 12. Right? That's why I said, can you predict? If you know this is 9, this one's got to be 3 so that the sum is 12. So let's go back up again now. We're done with our 3, correct? So we leave him alone. We're left with these two, R2 and R3. Parallel circuit. What do they get the same of? They get the same voltage, correct? So how much does the 36 get? 9 volts, right? How much does the 12 get? 9 as well, right? They both get 9 volts. So V equals IR again. The voltage through the, let's see, we get 9 is equal to 36I. I through the 36 then. What's that? 0.4? 0.25 I should say? 0.25 amps. How much should this guy get? What do you think? 3/4, right? 3/4. Because it gets a total of 1. This is using a quarter. The other one's got to get the other 3/4. So this is 9 is equal to 12, right? 12I. So I is going to be equal to 0.75 amps. I through the 12. Make sense? Right? It's a lot of work. I get it. A lot of redrawing and undrawing, things like that. The way this worksheet is done out, it's nice because it, this drawing lines up with this, so you're only making drawings once. Usually, with like my lower kids, I have them redraw the circuit again to unpack it. Usually, we don't actually unpack it; we just pack it, and then we're like good. But does that make sense? What do you think? Okay. So on the other side is one that you can practice on. We're not going to do it now for your own fun. There's a different circuit that you can practice with on your own time if you feel so inclined.